Hello everyone, welcome to Concept Bytes. I am Nitish, and in this Concept Byte, we will cover the concept of data analysis and with the help of a simple example, understand what it means. So let's get down to it.
The minimum basic requirement for performing any kind of data analysis is that we have a data set or data, right? Unless you have a data set, you cannot perform a data analysis. So for our purpose for the purpose of this video, I have made a dummy data set which you can assume contains the data for a certain set of people in a country. So they are identified by their identification number, which is in the first column, and then you have age, height, and weight for each of them. Okay, so you can assume you have this huge data set. The first step in data analysis is usually data collection. So in our case, we have already been provided with the data, so we might need to skip this step. But in general, in the real world, data sets reside in huge servers or computers called databases. So databases contain a lot of data stored in different packets, which one might need to pull for their analysis, right? So there might be a lot of data and you might need to pull maybe 1% of it for your analysis or 10% of it. So that depends on your objective and you pull it accordingly, okay? The next step is cleaning of the data. So cleaning, as the term implies, is the process of removing some kind of impurities from somewhere, right? So we are trying to clean the data or we are trying to clean something, meaning we want to remove some impurities. What does it imply in the data analysis context? Let's take the example of our own data set. As you can see, there is one observation which has height 0. But you know from common sense that height of 0 is not possible, right? So this data or this particular point might be an impurity in the data. Similarly, if you find any of the fields to be negative, you can say that is an impurity as well, because age, height, or weight cannot be negative physically, right? That is not possible. So there might have been some disturbance in the data or some kind of mistake in collecting it, right? After cleaning, we can proceed to processing of data. So what does processing mean? It implies transforming the data using a combination of some kind of statistical techniques along with some common sense and some kind of business sense to make the data easier for us to study. So what are we essentially trying to do here? We are trying to change the data or in a way process the data so that it becomes easier for us to study it. And different people might process the data in different manner. So let us take an example of one such approach. Let's say you have this data set and in this data set the height is in meter and the weight is in kilogram, which is the standard unit of measurement. But there are a lot of countries where there are different units of measurement, right? So for example, in Great Britain, people prefer measuring weight in pounds instead of kgs, right? So let's say if a British person wanted to be more comfortable with the data, so they can process it and update the weight to be in pounds. So they can change the weight to and convert it into pounds to make it more easier for them to analyze it. Okay. So this is one type of data processing. There can be other ways to process it as well. The final step of data analysis is inspection of data. So this step can be done or implemented in many ways. For example, we can take aggregation or aggregates like average, max, and min of different variables that are provided to us. So we can take, let's say, the average height of everyone in the data set, maybe the maximum age or the minimum height, etc. So on and so on. We can also combine different variables and take interesting observations and make interesting averages, maybe, or max and min values. For example, we can get the maximum height of all the adults in the population, right? Or maybe we can get the minimum weight of all the children in the population, and so on, right? So we can get a lot of insights from that. The second way, which in my opinion is more popular than the first, is generating visualizations or graphs. So why I think this is more popular? Because it is visual, it is much more global in a way, right? It is much more universal in a way in its approach, because everybody can understand it. So if you look at this graph, you can easily say that when the height increases, the weight also increases, and vice versa, right? In general. So that gives us a lot of insight into these two variables and the relationship between them. Like that, you can generate different types of visualizations for different sets of variables, or maybe analyze them individually if you want to. So you must be wondering, what is all this fuss about? Like, why are we going through all this trouble to understand the data, or get insights and everything, right? Why are we doing that? So the idea is, from the data we need to get insights, and from those insights we need to come to some conclusions. So once we have insights, we come to some kind of conclusion, and finally drive some kind of decision making. So unless you're performing data analysis as a hobby or just for fun, right, you must have some motive behind analyzing the data, right? Especially if you're working in a company as a data analyst or a data scientist, you will have some kind of motive behind them. So using it, you will try to drive some decisions. So in our example, let's assume that you're working as a data analyst for the government in the healthcare department, and they have asked you for some insights so that they can build a policy around children, around some kind of healthcare policy for children. So you will try to dig into the data and maybe look for everyone who is less than 10 years old, analyze their weight, maybe try to see if they are undernourished or maybe they are malnourished. And if you find that, you can go to your government and say that, okay, look at the data. I think that a lot of children in our country are malnourished or undernourished, and we should provide them with some kind of policy change so that they can have a better life or better childhood. Okay, so this is just one example. There can be hundreds of other examples as well. So let's have a quick recap. The data analysis process starts with data collection, which, as we saw in our case, is optional. Then it goes on to data cleaning, and we process the clean data. So the first three steps combined are also known as data preparation. Then you inspect the data, and finally you generate insights, and which goes to conclusions, and you drive decisioning. Okay, so this is the complete process of data analysis. And you should also appreciate the fact that data analysis is as much of an art as it is a science, right? Because as I told you, different people might have different interpretations of the data basis on what they want to see. So in a way, all of them, or maybe most of them, would be right. Okay, that is also true. So there are multiple interpretations that you can have for a single data set. So that makes it kind of an art. But the fact that you are using some mathematical analysis, you are using your analytical skills, makes it a science. So at least I believe that data analysis is as much of an art as it is a science.
I hope you have a better understanding of the concept of data analysis after watching this video. Do subscribe to my channel in case you want even more such simpler and concise explanation of such complex topics in the future. Thank you so much, and I look forward to your comments and feedback.